Okay, so as we get rolling here, with just maybe a little bit of a review from last week, because how many compounds up here are saturated? There are two. Okay, and then the reason that we say that we have three unsaturated ones, because these mean the same thing. These two compounds mean the same thing. The reason we say that is for the same reason that we don't put hydrogens on here. I was explaining this to the freshmen. Even if you had something as simple as pentane, okay, we know that it's saturated. You don't have to write a hydrogen atom in every time you do that. It's just time consuming. So when you see just the dashes on here, we presume or we know that these are just hydrogen atoms on here. And if it's going to be something other than hydrogen, it would tell you that. So for the same reason, for the red compound or upper left-hand corner, does anyone possibly remember that from 2 years ago, 2 or 3 years ago?
Benzene.
That is benzene. So that's why we don't write this compound like this. It's just simpler. Draw a six-sided figure, put a circle in the middle. The circle is illustrating that there's alternating double bonds and that each one of these carbon atoms also has a hydrogen sticking out on it. I mean, you can draw this, but you're really going to confuse yourself once you start putting derivatives and or intermediates on there, because this is called benzene because it's in a classification of family called aromatics, because we have, of course, you have aliphatic compounds. That's where, for our purposes, we call these three aliphatic compounds. This is a ring structure, and then this is an aromatic. Okay, so that's how we like to approach this as far as being the different types of hydrocarbons that we deal with, besides the oxygens that you see up there and some of the halogen derivative counterparts. So some of this is going to be somewhat new, but it's based off of old knowledge. So as you write these, we've already established that this is benzene here. Then one of the things that we would say, if something is branching off of that, then you would name that intermediate then. Okay? And for those of you who take the organic class next year, the most common place that you would put an intermediate or derivative on here would probably be up top here. That is the most common place. So then these also have common names, because we talked about the IUPAC system, that sometimes we have these compounds named and then, well, is it this compound or is it something else? And this also takes place here because some of the rules that we would follow with this, because, okay, and this is what we're talking about. It's new material, but it's based off of old knowledge. The clue that you would look at that is how many carbons do you have that are branching off of the ring structure. There's 4 total, okay? Because if you distribute this here, there's 2, there's 3, and there's 4. But these are 2 totally different, when I say derivatives, branching off of there, okay? Now, one of the reasons that gets to be more important is, we're just discussing this morning, where you see something called your omega numbers when it comes to different types of fatty acids that you might choose to take in your diet. If it's fish oil, it's probably a compound we call linolenic acid. And what that is that's fish oil, because it's believed that these types of compounds that we call omega-3s is what's healthy for your heart. And that's why people choose to take that type of a supplement. And some of you may give that to your pet as well. You might give them fish oil on a daily or every other day basis, because not only is it good for their heart, but it's also good for their hair coat. And for anyone who has a type of dog that sheds a lot, sometimes that could be a good reason to give that fish oil too, because it helps with the shedding process. Okay, so we've passed everything that is based off of old knowledge. Okay, so this was a bit of a review. Okay, we could probably figure this one out. This we talked about before, but it can be a little tricky. We'll explain why. So this is based off of old knowledge, but this is new up here. So would you like to go in order, or what is your preference?
Let's go in order.
Okay, so then if something is branching off of here, then just give me an example of a halogen. Okay, so then what that would mean is, okay, you name your derivative and then the parent compound. So in this case, what is your halogen derivative then? Okay, so it's not chlorine. Okay, it's chloro. Okay, so we've named this, and then we have chlorobenzene.
Wait, so where does benzene come from? Like, you just have to know that?
That's correct.
Other ones like it?
No, this is an exception to, there's nothing like benzene.
Only if it's like 6 of them and it's a double bond between all of them? It's just called benzene?
Yep.
Okay.
Wait, are the two up in the top, are those two separate things?
These here?
Sorry, on the left.
The red
ones,
ones.
yeah.
These here?
Are those both representing benzene minus the chloro on the top?
That's
Yes.
correct.
Okay.
Okay. Didn't we say that? Okay. Okay.
Sorry, I just.
All right. Well, no worries. That's why we ask. All right. So then, and what happens is we like to take this in a progressive manner, that it gets to be a lot more complex when you start putting multiple derivatives on here and common names, and then the reactions that accompany the aromatic compounds are for our purposes, are actually quite extensive, and I would say probably pretty difficult. And I think if you were to ask some of your senior, let's say, almost say classmates, but teammates or friends or whichever, it would appear that we are going a lot faster going through this than what you do with taking the organic class. But you also have to take into account that there's a lot of reactions that accompany all of these too. So it's more extensive maybe because of that factor, if you want to maybe mention that. But we want you to have a good understanding of that for those of you who do take that next year. Yes?
You know how for acids you add OIC? Where do you cut off in like methane to add OIC?
Okay. Just spell methane, but take the E off and put OIC.
See,
Okay? So that would take care of this, because otherwise what happens, you could add, like senior year, you could have a methyl group on here, and you could have maybe an ethyl group down here, or sometimes maybe you have two chloro groups on there. And then you would have to name the number and where they're located. But if there's only one on here, it's just understood that it's on the first one. You wouldn't have to do that. That's why we say if you wrote chlorobenzene, chances are you probably put it up here, because that would be the most common place that you would put that. Okay. So this one perhaps isn't too bad. You would want to find your parent chain first, which of course is how many?
5.
Okay. So then is it saturated?
Yes.
So that means the suffix has to be ane because it's saturated. Okay? So what is branching off of our straight chain here? Okay? So we have a chlorine, and then a methyl group. So then alphabetizing these, yes. Yes, so who's coming first here?
No, carbon goes first.
No, it's methane, so it'd be chlorine.
It's chlorine. Chlorine goes first.
Okay? So even though it's off of the second carbon, okay, because you do want the lowest number possible, but then this derivative starts with a C, this derivative starts with an M, so therefore you would alphabetize that first. So then we've got two derivatives on 2, 3, and I'm going to run out of room again. I think I can make a little more space here. 2, 3 dash dichloral, okay, dash, and our methyl group is on which carbon?
Four.
Be on the fourth one.
4-methylpentane.
Okay. So you think you're always going to have enough room, but it gets to be a little extensive when you start writing all of that out. Okay. Yes, 2, 3 dichloral 4-methylpentane. All right. Now, we said earlier this could be a little difficult because typically we say, what's the first thing that you should do with all of these compounds? What would you want to find first? Okay. So does this follow that same process, or is this just a little different?
It's an exception.
Okay. And the reason for that is if you went by the longest continuous chain, and there's always exceptions to different types of rules that you follow. It happens in general chemistry, and then of course here it happens with the organic portion. Because if you go up and over, you got a parent chain of 5. But if you do that, then you don't know what to name that if you're calling this a pentane molecule. But we know that this is not a saturated alkane because it's got a different functional family on there. This right here, COOH. And if you wanted to, there's nothing wrong with this if you did that at the end, because that is still saying the same thing. It's just not showing you the different types of structures. Now, the only time that we do this is maybe when we're writing out our fatty acids. We do write these like this, but the problem with that is if you get used to this, then when you have to go through different types of reactions that these go through, that COOH isn't going to make any sense. You'd want to have this structure here. Okay, so in a I won't say separate, but in a similar manner then, what is your parent chain then?
5.
Okay, and it is 5. You could say it's also 5. It's actually 6 if you go that way. But if you did that, well then, how would there's no such thing as 3 3-carboxy hexane, because then there are times when you're looking at two different, sometimes different families at the same time. It happens with alcohols and alkenes. That's more so of a upper level course. So if we have 5 carbons, then what is your prefix for that? Well, same thing up here. But then we drop the E.
And add OIC.
Okay, so now, if we just had this, that would be pentanoic acid. But there's something branching off of this, and which carbon is that happening on? Well, it would be the second one. Okay, so on our second carbon, what is branching off of here? You have an ethyl group. So then 2-ethyl pentanoic acid. This is the only time that you would ever put an ethyl group on the second carbon. And here's why. Because if we did this, okay, then we say, well, we're going to put an ethyl group on this second carbon. Okay? What is the possible problem with this? This is 7, but if you go up and over this way, it's what? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 going the other way. So you can have an ethyl group branching off of the second carbon, but it can't be with a saturated hydrocarbon. It just can't do that. Okay.
That was a saturated hydrocarbon that we just did.
What we just erased, yes. Okay, because a lot of this is saturated, but if this is going to react with anything, which it can, when it forms an ester, which maybe this is the compound that goes into clothing. You might say, how could this go into clothing? Well, we just gave you maybe a clue when we said ester. What does that have to do with clothing? Yeah, polyester clothing. It's actually a chemical reaction that you use to synthetically make polyester, or polyesters, I should say. Okay, so front row, how are we doing so far? We on the bus here?
I'm fine with this. I don't know what I'm doing on that.
Okay, back row.
I had a question. So when you're doing like an acid, do you have to label where the O and OH are, or is that just assumed it's on the end?
It's going to be on the first one. That's why this happens on the second one.
Okay.
Yep. And it can be on this side too. You can have a double bonded oxygen and a hydrogen, or an OH group over here. And then you could have your acid on this side as well, or your functional group. And you could say that this is also almost resembles 2 families at the same time, because it looks like you could say a ketone and an alcohol at the same time. Now, ketone doesn't mean anything to you right now, but that's another organic family that you discuss next year.
So is it only at the end, or can it be anywhere?
It's either on this side or this side. No other place.
You don't need to label that ever. It's always just assumed, like you say, pentonic acid.
Yeah, because once you see this suffix is telling you a carboxy group, and a carboxyl group is just that. Okay?
Just one thing.
Yes.
How many isomers of pentane are there? There's only 2?
There's only 2.
So am I thinking about this right? Is it a trick question?
I don't know. We'll see when you hand it in. Then we'll tell you whether you're thinking of it correctly. It's probably the most difficult question that you would deal with when it comes to isomers, because there is only 2. And it's so brand new to yourselves. And I'd like to think that we probably had discussed that when you were a freshman. We just don't remember. And sometimes the easiest way to do that when you're drawing isomers, name them at the same time, because then that gives you a clue if you're looking at the same compound.
Well, this is pentane and this is pentane.
Okay. So now, as we are, which would you like to do, the more difficult one first or not? Or it doesn't matter?
More difficult.
Do what? Which one?
So the difficult.
No, do the bottom one.
Do the one with the slants.
It's
Okay.
just a double bond. Is it not?
But why are
There's
the slants?
That's why.
Because of double bond?
No.
Okay, yeah, do the double.
Because what you're normally used to seeing is something like this. That's what you're normally used to seeing. But when you change that geometry on this, and it doesn't even have to be straight, it can be going in a zigzag pattern to where it doesn't have to be straight. But once you do this, okay, it's all about the different types of bonds that you see going around that alkene, because again, it's no longer saturated, it's unsaturated. These pi bonds in here is what they're really called, actually can break really easy. It's when you have these single bonds in here, there's different types of forces that hold those electrons in there, okay? That's what makes it so much more difficult to react. But these are very, very weak. These are quite strong. And then you might say, okay, now wait a minute. You just said that this is really, really weak. So does that mean that these double bonds are weak as well? Absolutely not. Okay? There's another time where this is an exception to the rule. These double bonds are extremely, extremely stable. This is really, really unstable. Okay, so there's two different ways to look at that, and to me, it would be the best way of looking at that if you were to make a road trip from Seattle, Washington, down to Miami, Florida. I understand you say, well, the closest distance is going to be a straight line. Well, that's true. But if you're starting in the extreme northwest, well, chances are you might go down like this and then over, down, and then now we're down there in Miami, okay? But the point we're trying to make here is these are in opposite directions. Just like these hydrogens, they're pointing in opposite directions around that double bond. I wouldn't say they're trying to get away from one another. It's just how this double bond is somewhat affecting those hydrogen atoms. So then the reason that is significant is because you can also have something like this instead. Notice we had that zigzag pattern. Now it's just up, over, and down. And those are two totally different compounds because they would have different chemical properties. So what this means is we're still calling this based off of old knowledge. Find your parent chain, which is 4, and then what organic family do we have?
Alkene.
Okay, so then that means we've got some sort of butene molecule here, which we do.
And it's on the second one.
It's on the second one, but because of this, if this would be really simple, okay, we would just call this what?
Butene. 2-butene.
You call this 2-butene. But because of this, okay, because remember we said we're starting in one part of the country, we zigzag through, and that would be kind of like a transcontinental drive.
Railway.
Okay, well, transcontinental railroad means, yeah, the same type of concept. You're taking two parts of the country and connecting them. But in this case, this is what we call a trans compound. So it's what we call trans-2-butene. When they're pointing in opposite directions like that. Okay? Because go by your hydrogens. They're pointing in opposite directions. But if they were to be pointing in the same direction, well, then that's a different category we call cis-2-butene. But this is how we had it. So that's where that belongs. Trans-2-butene. Okay, something just a little different than what you're used to seeing. Okay, and then finally we can move on to our last one here. So is this an alkane? Is it an aromatic? It's not benzene.
Good guess, pull it out.
It looks exactly like benzene.
There's 7.
Wait, is
Cycloheptane.
Yeah, it's definitely,
Pentane.
it's definitely,
Two.
2, 4
Hexane.
cyclohexane.
Oh, we eventually said the right one.
Cyclohexane.
2, 6 cyclohexane.
Okay, so we know that it's a hexane molecule because these intersections are where carbon atoms are located. And then there's nothing written on here, it's just dashes, so we know that those are hydrogens. This is telling you it's something other than hydrogens, but it's still going to be cyclohexane. Okay? So then we said this a long time ago. Your clue for this, how many carbons are in this derivative?
4. Well, there's 3 right there.
Okay? So then what this means is this is probably the preferred way that a lot of chemists would write this. Okay? So let's look at this and say, remember, we would say that X marks the spot, that where this is bonding, this derivative. Okay? So if we were to maybe turn this just a little bit, here's your X. That's making a carbon-to-carbon atom now, or bond. So this carbon's here, this carbon's here. Do we follow so far?
Yes.
Okay. So then this is a carbon-to-carbon bond, just like this is a carbon-to-carbon bond. Okay. So what is branching off of that carbon? There's a hydrogen. And then what is CH3? It's not methane. And how many of those do you have?
2.
Perhaps that looks a little more familiar.
Isopropyl.
That's an isopropyl group. Okay? That's why this is probably the preferred way that people would choose to communicate this knowledge. It's a lot simpler than writing this structure here.
How do you write isopropyl? I don't know how to do that.
ISO.
That's all you write? You just put isopropyl?
Just isopropyl. Now, if you like doing that, I just do that when we're establishing what your derivatives are. But if you put a slant on your eyes, it's not wrong. It's just something that I prefer to do when we're putting these on here. So then, does this group come first or this one?
The first one, because it's an I, right?
But this is a prefix, though.
Oh. Can I ask a question on this?
Is that going to stop you?
Methyl goes
Be nice.
first.
Can you wait
All right,
1
we
second?
got it. Okay. Okay, now,
Probably be 6 cycle.
we were, establishing this. We're trying to say which one comes first. But isn't this a prefix, though?
Yeah.
Don't we ignore prefixes?
Yeah.
Yeah.
We do, except
For this one.
for this one.
Erg.
Okay?
So it's going to be 1.
So that's why, even so, when we named this, okay, you're not going by the D for dichloral, you're going because of the C, because the di is a prefix. This is also a prefix, but this is an exception to that rule. You go by the I, not the P. Okay, so then we've got, where is that isopropyl group located? It has to be on the first one because you want the lowest number. Just because it's the first one, it doesn't necessarily mean that it's going to be here. I mean, it can be, but you have to assign this a number of 1, and you would have to put the number 1 dash isopropyl dash
Dash 3.
3
What's 10?
dash methyl cyclohexane. Okay. All right, so back row. We all right? Okay, front row.
Yep, sure.
Okay, and middle row. And middle row. And middle row. And middle, okay. All right. So you have a paper that's going to be handed out here shortly. And then tomorrow you're given time to work on these. And it appears on the schedule that Wednesday you are busy all day in the gym. Except for one of you.
I have a question.
I can certainly find something for you to do.
Quit asking.
I can find something.
Well, I can find something for you to do too.
If I get on
You don't probably want me to find something for you to do, but I will be more than happy to do so.
Okay.
Okay. All right, so that's all I have. We'll catch up to you next time.